Okay, so we're going to graph tangent, cotangent today, and here's the idea. I want you guys to think about this for a second. You're going to need your calculators as well. But in terms of x, y, and r, how do we express tangent in terms of x, y, and r? Y over x. You look at that sheet, it says right here, tangent is y over x. Tangent is y over x. Okay? Good news there. Now, I want to help you understand how tangent behaves. I'm going to help you understand how tangent behaves. If we look at the unit circle, I think you can kind of start to see how it behaves. We take y and divide it by x. So if we have the tangent of 0, the terminal point through 0 is 1, 0. If you take y and divide it by x, what do you get? Yeah, 0 divided by 1 is 0. So at 0, tangent is 0. Now, if I move up to 45 degrees or pi over 4 radians, I have pi over, or square root of 2 over 2 divided by square root of 2 over 2, which is 1. Okay? And so the tangent of pi over 4 is 1. Well, then we get up to 90 degrees or pi over 2, and you have a terminal point of 0, 1. If you take 1 and divide it by 0, what do you get? Undefined. You can't divide by 0. So let's look at our calculator and see what happens as we get close to there. All right? In fact, let's first go to mode, and let's make sure we're all working in radians. And then if we go into y equals, let's type in tangent of x. And then let's go to our table settings. So second window, that's your table set. Let's make sure that our independent variable is set to ask. So we're going to plug in a bunch of values for tangent. We're going to see what we get. Oh, wait a minute. I'm sorry. If you go back to mode, let's work in degrees. I think we can understand degrees better for this portion. Okay. And now we go to our table. And if we go to our table, again, if we type in 0, you get the tangent of 0 is 0. If we type in 45 degrees, you get 1. The tangent of 45 is 1. We've already encountered that. Let's plug in something that's closer to 90. Let's plug in 80. How about the tangent of 80 degrees? 5.67. So what's happening to the y values? They're getting bigger. Let's try 85 degrees. 11.43. Let's try 89 degrees. 57. Let's try 89.99. 5,229. So, any guess where it's going towards? Infinity. Now, if you think about it, y over x, rise over run. That's the same thing as what? Slope. Well, the slope of a line that's straight up and down is what? Undefined. We don't know what it is. If you would go to the other side, it's at 89.99. Let's go to the other side of 90. If you try 90, you're going to get error. But if we try, say, 90.001, you can see that you get negative 57,296. So whether the slope is positive or negative, it's undefined. It does not have a defined value. Our good friend Benjamin Jones carries out this argument that we can't say undefined, that we must say plus or minus infinity. But again, that is undefined because whether it's positive or negative. So Ben Jones, his theory has not been published yet, and so we tend to just disregard it as hodgepodge. So we'll leave it at that. So that gives us an idea about the nature of tangent and the way it behaves. Generally speaking, you're going to see tangent, cotangent represent these forms. Y equals the tangent of bx minus c. Tangent is positive in which quadrant? First and third. That means it goes positive, negative, positive, negative. Tangent, instead of taking an entire 2 pi to repeat itself, tangent repeats itself every pi. And we'll divide that value by b. So that's new. Tangent and cotangent, instead of repeating themselves every 2 pi, they repeat themselves every pi. So you'll take pi divided by b, and that will be the period. The horizontal shift, same thing, bx minus c equals 0. Solve for x, and x will represent your horizontal shift. Now, these are the general graphs for tangent and cotangent. I give these to you on the back side of your notes, and all the parent functions are listed. And so let's generate these. Tangent repeats itself every pi. Now, I'm going to write out a number of repetitions for the graph of tangent. Now, everybody said, well, Mr. Getz, why don't you divide it up into 4 spaces on each side? Because we don't need to do that. Tangent repeats itself every 2 quadrants as opposed to every 4. So I'm only going to take each period and divide it up into 2 pieces, not 4 pieces. And you'll see that in a second here. Here's what we know about tangent. Tangent of theta equals 0 at period. Tangent theta is undefined in between periods. Remember, we said the tangent of 0 is 0. That means that the tangent of pi on the other side is 0 as well. It's halfway between at tangent pi over 2 that is undefined. If tangent is undefined at pi over 2, that means that the graph never has a value at pi over 2. And if graphs never have values at certain domains, generally speaking, we have asymptotes. These are called vertical asymptotes. Halfway in between the periods. At the period, tangent is equal to 0. Let's look at this part right here. This is from 0 to pi over 2. From 0 to pi over 2. At 0, tangent's equal to 0. What happens as we approach pi over 2? What did we say? It gets really, really big. So it's going to go like this. And behind it, it does the same thing. It's just negative. Because this represents the 4th quadrant, and this represents the 1st quadrant. It's positive in the 1st, it's negative in the 4th. That's what's represented here. And so that happens all the way through. Tangent is equal to 0 at the periods. It will go through, and it will have that shape. Very similar to a cubic, but not a cubic. A cubic will continue on for all real numbers in the domain. This does not. Are there any questions how I generated the graph of this? Tangent starts down and finishes up. Cotangent is exactly opposite, but I want you to think about something here, okay? Tangent of theta equals 0, okay? What is the reciprocal of 0? Undefined. If you have 0 over 1, that's equal to 0. But if you have 1 over 0, that's undefined. So since tangent and cotangent are reciprocals of one another, that's what we're going to have. Cotangent and tangent have reciprocal values. So if tangent is equal to 0 at the period, cotangent of theta is equal to undefined at the period. And cotangent is equal to 0 in between. So that makes them different. So I'm going to mark out the pi's again. I have 2 pi. I have pi, 0, negative pi, negative 2 pi. And it says that cotangent is undefined at the period. So what should I do through these periods? Draw vertical asymptotes right through these periods. And cotangent is equal to 0 halfway in between. So I can plot where it goes through 0 halfway in between, just like so. Now, if you think about it, they're reciprocal values. So if they're reciprocals, wherever tangent is really big, that's going to be where cotangent is really small. So it's going to go the opposite way. And those are the parent graphs for tangent and cotangent. Generally speaking, this is the easiest section for graphing. You guys learn how to graph sine and cosine. I would say that that's most difficult. If you don't know how to graph sine and cosine yet, then what we learn tomorrow, secant, cosecant, will be infinitely more difficult. That'll be very difficult. But as long as you know how to graph that stuff we did yesterday, those 6 problems, you should be golden. So hopefully we're good to go. All right, let's try some of these problems. You can see how basic they are. The first one says y is equal to tangent of pi x. What I need to do is I need to figure out the period. And the period is equal to pi divided by b. What is my b value? Pi. So I take pi divided by pi and I get 1. Now, this is where the kind of the discussion came up second hour. People said, well, Mr. Gentz, you used to just take that period, which was 1, and mark it all the way out there. The reason why I did that is I needed to divide it up into 4 more sections, didn't I? And I wanted to give myself some room. Well, right now, if the period is 1, notice that tangent repeats itself every 1, and that's every 2 quadrants it's going to be. So I don't have to have as much space there. So that's why I put a 2 over here. I just wanted to show more repetitions. If you wanted to put a 1 there, that's fine. Then you would just divide it in half once. Since I have a 2 there, I'm going to have to divide this in half twice. So you can do whatever you want. We'll do the second one the way that we did first hour so you guys can see what we did and maybe ask questions there. So I have it divided up. Now I ask myself, is tangent defined at the period? Is it equal to 0 at the period, or is it undefined? It's equal to 0 at the period. So what I'm going to do is I'm going to put some marks right at the period, reminding myself that it passes through right through those spots. So what happens in between then? Vertical asymptotes. So I draw my vertical asymptotes. And then does tangent start down and finish up, or does it start up and finish down? Starts down and it finishes up, just like that. So if you decided that you didn't want to do all of that and you just wanted to put a 1 out there instead of the 2, then what your graph would look like would be something like this. Wait a minute. Is that the one I use? Yeah, I think I do. So that this would be what your graph would look like. Okay? So it didn't do it quite perfect, but so this is just showing from 1 to 1. And if that's how your graph look as opposed to mine, that's fine. That's fine. I just chose to show it. Go away. How does it go away? Oh, there's a box. All right. There we go. So you can see that, I showed 5. If your viewing window only showed 3, that's okay, as long as you mark your period appropriately. So we'll do that with this next one. So now I have tangent of -2 tangent of x. And we'll talk about what the -2 means in a second. But first of all, what's the period? Pi divided by 1 is pi. Very good. So instead of marking out 2 sections of the period, I'll do what we did first hour, which is just mark out 1 section of the period, which would be pi and -pi. That's what they wanted to see. Okay? Is tangent equal to 0 at the period or undefined at the period? It's 0 at the period, so I mark it going through 0 at the period. What happens halfway in between? Vertical asymptotes. Nope. How many parts am I dividing the period up into? 2, because tangent repeats itself after 2 quadrants as opposed to 4 quadrants, where sine and cosine take 4 quadrants to repeat themselves. So that's what's happening. I'm just showing more repetitions. You guys generally showed 1 full period. I've just shown 1, 2, 3, 4, 5. So just however many you want to show, you get to really decide. I've divided it up into 2 congruent sections. I'm good to go. Okay, what do you think the negative does? Flips it. Instead of starting down, finishing up, it's going to start up and finish down. The 2 actually creates a vertical stretch, and you don't have to worry about it at all. You don't have to factor in this 2 at all, okay? You should know that it's going to stretch it vertically, but we're not really concerned. We're more concerned about the negative, and that's going to make it start up and finish down. So that's how we're going to draw it. We're going to start up, and we're going to finish down. What do you think? Easy or difficult? Isn't this nice? So this is a lot easier than what we dealt with yesterday. Any questions on what we've done so far? We'll be able to finish off the other 2. You guys will have a lot more time to work than last class did. They had a lot more questions on this stuff. Sure nobody has questions? All right. So I'm going to erase this, and then we're going to move down here. Now we'll do a couple cotangent ones. So for C, I have cotangent of x over 4. How do I figure out the period? Pi divided by 1/4, which is 4 pi. So I'm going to, I like where I show 2 sections of the period on each side of the axis. So again, I'm going to choose to go 4 pi and 8 pi. Now again, second hour kind of got mad at me. They said, we just want you to do 4 pi. Well, go ahead then. You do it the way you want. No. Yeah, you could go 4 pi on one side and -4 pi on the other side. I'm going to go -8 pi. Because I get to do what I want. Now, cotangent, is cotangent equal to 0 at the period or undefined at the period? Undefined. So at the period now, I have to draw vertical asymptotes. So everywhere I have a period, vertical asymptotes. So what's going to happen halfway in between? That's where it crosses over the x-axis. It makes 0 there. Cotangents start down and finish up, or start up and finish down? Starts up, finishes down. Piece of cake, upside down. What do you think there, Devin? You like that? What do you like about it? So is macaroni and cheese. You like macaroni and cheese? Oh, now we're talking about food again. We had spaghetti last night. And then for Valentine's Day, you know what I got for my wife? A chocolate extreme blizzard. That's the way to a woman's heart right there, isn't it? What? Oh, I could have come and got him from Terry. That's right. You're the Dairy Queen. You're the Queen of Dairy. I could have dropped off my kids and you could have watched them for a while and played with them. We could have caught a movie or something. I tell you what Micah did the other day. He was standing. Did I tell you about the rock in the car? Oh, yeah. So he, so 2 days ago, my wife calls me at 3 o'clock, and I'm teaching people in here, and she calls me right on this phone, and she's crying. She's going hysterical. I said, "What's going on?" She said, "Micah was standing on a gas can in the garage, and it obviously went out from underneath him, and his head went straight into the snowblower." And so he had this huge, massive goose egg right on the front of his head. So she's like, "What should I do?" I said, "Well, she said it was close to his eye." So I said, "You take him in, because if it's close to the eye, maybe he could have some fluid back there. Who knows what happened?" Turned out it was higher up. It was about middle of his forehead. So I got home late that night because I had registration. So next morning, he always wakes up. When I get in the shower, he wakes up. He hears the shower running, he wakes up every morning. So he comes upstairs and I see him. He's just got this massive blue bump right on the protruding on the front of his head. You've all had a goose egg before, right? Yeah, it's amazing how fast your head swells up, isn't it? Anybody ever have stitches on their head before? Raise your hand if you have stitches on your head. You guys ever notice when I get a haircut, sometimes I have this empty spot back here? I got a scar back there. My sister pushed me off. I was jumping on her bed one time. She pushed me off, and I hit my head on the dresser. The car story? Oh, I'll tell you it after we do this one. How about that? Okay. All right, you guys are awake now. We'll do the last one. Uh, what's? Yes, I do love my son. I love him. I don't love sometimes the things that he does. Just like you, Nathan, I love you, but I don't always love the things you do. I don't like that you draw pictures that are not about mathematics during math class. All right. What's the period? What's the period for letter D? Pi divided by pi over 3 leaves me with 3. So I mark out 3, 6, -3, -6. Is cotangent equal to 0 at the period, or is it undefined at the period? Undefined. The negative will flip it upside down. Very good. Charlie, don't listen to Nathan. Okay, so there's my graph. What happens halfway in between? Crosses the x-axis. It achieves its 0 value. And cotangent, does it start up and finish down, or start down and finish up? Starts up and finishes down, but because it's negative, starts down, finishes up. Okay. You guys got it. There's your assignment. It's also posted on the board over there, page 451, 1, 2, 5, 6, 19 through 22, 33, 35. Your test looks like we will probably test next week, Wednesday. Tomorrow we'll graph secant. On Friday, I am not here. I have a meeting all day at the district office, so you guys will be given a work day. So tomorrow we'll graph secant and cosecant. So on Friday, you guys will have a work day. I will add to your assignment for Friday. You'll have a substitute. You had a whole work day yesterday. You have a whole work day Friday. I don't know what more to do for you. Thank you. Rock story now.